Our goal is to focus on sampling procedures or sampling principles and strategies. Suppose we wanted to answer the research question: what is the crash rating of a Toyota Camry car made in the year 2020? You agree with me that the target population would be all Toyota Camry cars made in the year 2020. And the parameter of interest or characteristic of this population that we're interested in is the crash rating of all such cars. Well, do you think it would be reasonable to crash all Toyota Camry cars made in the year 2020 just to get an answer to this question? Absolutely no. What might suffice would be to select a few random sample of this population of interest, take them into a controlled environment, crash, and get the data value that we seek. So you see, in most processes, to answer research questions about a given population, when it is impossible to collect data from all units of that population, we'll need to take a few select group that will represent that population of interest. This is a process called sampling. In other words, sampling is the process used to select a portion or subset of the larger target population of interest. So again, just to emphasize, if we have a research question that says, over the last 5 years, what is the average time to complete a degree for Duke undergrads? It is Duke University undergrads. Well, the population will be all Duke undergrads or graduates, and we'll take a sample from that what? Population. This process of selecting the sample from the population is called sampling. And of course, the target population will be all Duke graduates, and the possible what sample can be drawn from that population. Our goal in selecting a possible sample is that the characteristics of the sample should be a good reflection, a very close reflection of the entire population. Doing this helps to minimize systematic bias from crawling or creeping into our statistical results. With that said, let's delve into very common 4 statistical or random sampling techniques. So these are called random or statistical sampling techniques that we're about to discuss. These are techniques that, to a reasonable extent, guarantees that the sample selected from the population tends to represent population characteristics, and that minimizes systematic bias in the long run. So the first one is called simple random sampling technique, SRS, simple random sampling, otherwise called SRS. So consider if I had about 30 students in a class. If I wanted to select a sample of 5 students to represent that class, what would I do if I were to use simple random sampling? I might have all students write their names on a piece of paper and put it in this hat. So at the end of the day, I'll have 30 pieces of paper of the same color, the same size, all wrapped up to the same size. Then I might ask a random person to shake that hat very well and pick out 5 names. By so doing, I have engaged in simple random sampling, which is a selection process, that guarantees that each and every member of that class or each and every member of the population, that each member of the population has an equal or fair chance, equal but non-zero chance of being selected into the sample, of being selected into the final sample. Well, You've seen examples of simple random sample when you use a raffle draw to select winners. So that would be a very good example of simple random sampling. If you use a random number generator, that would randomly select what? Some numbers at random, probably to authenticate your access into your private email. So those are very good examples of simple random sampling. It guarantees that those who are selected based on the rule of chance. Another very common statistical or random sampling technique is stratified. Let's write that clearly. Stratified random sampling. Stratified random sampling. Okay. Consider this population. So this is the population of interest. Our goal is to select a sample from that population. But what we immediately notice at the beginning of the process is that this is a heterogeneous population. That is, it has units that have distinctive characteristics. You have the red faces, the purple faces, the green faces, and our goal is to select the sample from this population in such a way that the final sample reflects this heterogeneous characteristic of the population. So how can we go about this? One way to do that is to use stratified random sampling. So if I explore this, I have different colors. I have green colored faces. I have red colored faces. And then I have purple colored faces. Then in total, what is the number? So the number in the population for green faces, there are 14 green faces in this population. All right. And for red, you have 21, and purple is 7, for a total of 42 faces. So, how are we going to select the sample from the population using stratified random sampling? The first step is to stratify the population into non-overlapping groups. That is, we're going to simply select what? All green, apart from all red, and apart from all purple faces. So we have 14 green, 21 red faces, and 7. The way we're going to finally select the sample is going to reflect the ratio of each subgroup relative to the population. So, for instance, for green, we have 14 out of what? 42 faces that are green. If our goal is to select a sample of size 12, that means that I want 14 out of 42 times 12, which will be approximately 4. So that means from this group of what, 14, I'll use simple random sample to select 4 out of this subgroup. Similarly, 21 out of 42 in the population were red. So I'll multiply that by the sample size I want to pick. I want to pick 12 people to represent the population. So that'll be approximately 6. Then finally, I have 7 out of 42 who are purple. So 7 out of 42 of 12, how many would that be? That would be 2. So that gives us the total of what? 12 that we want to select. So I will use simple random sampling to what? To select 6 out of this 21 and then 2 out of this what? 7. This group will represent my final stratified sample. That is that is stratified random sampling. Now let's look at the third one. This is called systematic This is called systematic or 1 in K random sampling plan. Now, what does this involve? Well, first of all, we note that the population size, that is, the count of everyone here, is represented by capital N, and that is 18. And I would decide what my sample size would be. How many people do I want to select to represent this group? That is my sample size. That will be lowercase n. I want 6 people to represent this group. So the first step would be to determine or determine my sampling interval. My sampling interval in this case is K, and that will be population size divided by sample size. In this case, that will be 18 over 6, that is equal to 3. So my K is equal to 3. So this is a 1 in 3 sampling plan. In other words, I plan to select 1 in every 3. Okay, how am I going to select 1 in every 3? I would get a sampling frame. The sampling frame would be a list of all of the population units listed in some order. I might use their last names to list them alphabetically because that will be subject to chance. So based on this, I would use simple random sampling to select 1 out of the first what? Out of the first K, out of the first K equals 3 members. So for instance, this is the first group of 3. I'll name them 1, 2, 3. Then I'll put 1, 2, 3. I'll put it in a hat like this. Then I'll randomly draw one number. Let's say I drew number 2. It means this person, number 2, makes it into the sample. Then I will pick the next what? 3 again. Since we said our sampling interval is 3, that means from 2 I'll count 1, 2, 3. The next person is this person, also makes it into the sample. So it appears that for every 3 persons, the second person makes it in because I am jumping in jumps of what? 3. So at the end of the day, my sample units will be persons number 2, 5. Remember, I'm jumping in 3s. 5 plus 3, 8. 8 plus 3, 11. 11 plus 3, 14. So these people, and 14 plus 3, that will be 17. These people will make it into the final systematic sample. Okay. Then finally, we have another random sampling process called cluster sampling. This sampling technique advocates for first subdividing the entire population into clusters or subunits, which might not be of the same size, and in each cluster, they might not have similar characteristics. In this way, cluster sampling differs from stratified sampling. In stratified sampling, the division of the population is based on some stratified variable that ensures that in each stratum or in each layer, sublayer, the units are very homogeneous in nature or very similar in characteristics. In contrast, in cluster sampling, the units within each cluster may not be very close in characteristics. So I can have this numbers of clusters, and let's see, let's grab this. I'm going to number those what? Clusters 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And for that group, I will put the numbers 1 to 13 in a hat. Then I'll use simple random sampling to choose a predetermined number of values. Let's say when I use simple random sampling, I picked 1, 7, and 13. Everybody who is in 1, 7, and 13, these will constitute my cluster, my final cluster sample. That is it. You see, for any of the statistical sampling techniques, the goal is to get a random and representative sample that mirrors the population characteristics. So, we now want to explore some examples of non-statistical or non-random sampling techniques. A very good example is convenience sampling. In this case, consider if I was standing right here and to select a sample to represent this group, I only selected these people as my sample. You agree with me that the sample demographics seems to have left out the green group. So as it stands, in convenience sampling, sample members are selected based on ease of selection, or accessibility. And that is a problem. In other words, there is no underlying random sampling plan or random selection plan. So usually results that you get from convenient sampling plan may oftentimes be affected by systematic bias. Let's consider an example of this in reality. If a student interviews classmates in its algebra class to determine how many pairs of genes a student owns on average, that is the research question, what type of sampling do you think was used by the students? Well, to answer this research question, if the student is only interviewing or collecting data from his classmates, that is very convenient, you might say. So I would argue that the sampling plan used in this case would be convenient sampling, because those in his class may not be a very reasonable or representative sampling of all students. Let's see more examples. In this example, we would like to determine the type of sampling used. 1. A teacher puts students' names in a hat and chooses without looking to get a sample of 3 students. Well, all names are going in a hat. That means every student has an equal but non-zero chance of being selected. I would argue that this is a case of simple random sampling. Question 2. A principal orders t-shirts and wants to check some of their name to make sure they were printed properly. So she randomly selects 2 of the 10 boxes of shirts and checks every shirt in those 2 boxes. So each of the boxes is a cluster, and you have only selected 2 clusters out of 10. That reminds me of these boxes here, these clusters. So this is an example of cluster sampling. 3. A politician asks his neighbors their opinions about a controversial issue. Well, asking your neighbors, most likely than not, they do want to say something that might what? Suit your ears. So, what would that be? That would be a case of convenience sampling. All right. And then next, let's see. 4. A manager at a pizza shop wants to start visually checking finished what? Pizzas. But she doesn't have time to check every pizza. So she decides to check a random pizza in the first 20 made each day and then check every 20th pizza thereafter. That would be systematic or 1 in every 20 sampling plan. 5. A school chooses 3 randomly selected athletes from each of its sports team to participate in a survey about athletics at school. So, in each of the sports team, they will be very similar. They know how to play similar sports in each of the sports team. And to select 3 out of every, these will be reflecting the characteristic that, or the plan we discussed under stratified random sampling. So this will be an instance of stratified random sampling plan. 6. A store prints a request on each receipt asking customers to fill out a customer survey online if they are willing. Well, those who might only complete this are those who either feel strongly about the service or who feel otherwise. That would end up with convenient sampling plan. And finally, each student at a school has a student identification number. Counselors have a computer generate 50 random identification numbers, and the students identified associated with those numbers are asked to take a survey. So I would say in this case that this would be a case of simple random sampling.